We're going to be talking about the cone of vision today. So what you're seeing in front of us is a one-point perspective construct. We're starting with the center of vision and the horizon line as always. And we have a multi-tool down at the bottom. It's a triangle with a compass inside of it and a protractor. So you can make circles, you could also tell angle differences. And I've got the 0 point of the protractor on the station point where, what we're deciding is the station point here. And then 0 is centered. And as you go, if you look at the triangle, you can see that there's numbers every 10 degrees. So if I wanted to create something that's 60 degrees, I would go from the station point, and then I would count 30 degrees over to the right, which is what I did here. And I drew a line up to the horizon line. And I created that 60 degree cone of vision mark. Now this mark, it's very important to understand that this mark is in relationship to the center of vision. We center the circle for our cone of vision in the center of vision, and then we hit that mark on the outside in a perfect circle. That means that all the way around the center of vision, the cone of vision is always the same distance away from the center of vision. Now we're creating a portal here that is fitting inside the 60 degree cone of vision. It's not filling up the whole thing, but notice that bottom right corner. That bottom right corner is touching the 60 degree cone of vision. The closer you are to the cone of vision, the more linear perspective you're going to get in 60 degree cone of vision. The closer to the horizon line you get, the further it becomes about shape, right? Anything outside of the 60 degree cone of vision is going to be distorted. Now I just created a unit, and I said that was going to be 4 feet. So right now I'm just setting up my units, or my distance line. My distance line is going to be from my center of vision to the station point. I don't have a particular scale that I'm going with, other than knowing that the unit that I'm using is in fact 4 feet. So I don't know how far back I am. I just want to make sure that there's an even amount of units. So I'm grabbing everything, even the original unit that I created, and I'm scaling it down until that bar that I just created is within the station point and the center of vision. And then the 4th unit down just happens to line up with that portal. If not, I would have moved the portal around so that the bottom of the portal was 4 units down or whatever. That's totally arbitrary. I'm also adding the measure bar at the bottom of the portal. I am considering the bottom of the portal the ground, so that would be the ground line, and I'm centering one of the units where the distance line meets the measure bar. Now I'm just creating the Z orthogonals, so I'm going to go ahead and just set up a grid using this setup right now. Now keep in mind that these units happen to be 4 feet each, and we are well within the cone of vision. At least all of our canvas, all of our portal is well within the cone of vision. So we're just going to create a grid here and see how it looks. So we're just doing the thing that we normally do. We put the measure bar on the ground line. We have equal divisions. Those equal divisions are all going back to Z. And then we're going to create our X orthogonals. Well, we have to create, our measure point first. And we have 2 ways of creating our measure point. We can look for 45 degrees to the left or the right of center, which would give us a total of, it would make sure that the line going from the station point to the vanishing point is the same distance as the vanishing point to the measure point. This only works in one point, but I'm going to employ both of them, both of the ways of going about creating a measure point. Now we're going to go from the vanishing point to the station point. We're going to create a line that goes between them, and then we're going to rotate that up from the center, or from the vanishing point over to the right of the horizon line. So now we have two measure points, one on the left of the vanishing point and one on the right. So like normal, we know that each vanishing point has two measure points. And the rule of thumb is the measure point is the same distance away from the vanishing point on the horizon line that the station point is from the vanishing point. So that's why I showed you two different ways of creating the measure point. So now that we've got the measure point, we're going to go ahead and cross our reference lines. In one point, it just so happens that all of these lines are considered reference lines, but in 2 point, there will only be one reference line per anchor point. So we're creating this anchor point over there on the left-hand side where the measure line meets the measure bar. And now that we've got that measure line in place, wherever that measure line crosses the unit or the z orthogonal to the right of that anchor point, at each interval along that line, we create another x orthogonal. So wherever those lines are intersecting with that measure line, we're going to create another x orthogonal. And all this is doing is it's telling us that given the relationship between the station point and the vanishing point, and the relationship of the canvas to the cone of vision, which the cone of vision is always in relationship to the station point to the vanishing point, right? 60 degree is always around halfway between the vanishing point and the station point. So now that we've got that relationship, all we're saying is that as long as we're making a grid within our portal that relates to the rest of the construct, the rest of the perspective system here, as long as we do that, and we're using our measure points accurately, we're using our station point and our vanishing points accurately, we're using our calculation of our 60-degree cone of vision, as long as all of that stuff is accurate, then every one of these squares that we're making on the ground here are proportional. But in this particular case, because we're dealing with a 60-degree cone of vision and 4 feet, we have something that is more of a standard lens. Now this changes if you change the scale of those units. And unfortunately, people will change that scale to be way outside of what is standard, right? So if 60-degree cone of vision is standard, then chances are the best images that we can create are going to be close to the subject matter that we're trying to create. And given that, 4 units or 4 feet per unit seems to be a good number. So I would go usually 1 foot to maybe 6 feet per unit if I'm doing a standard lens. Whereas you'll see in a second where we're going to pop over and create a longer lens scenario, creating a 30-degree cone of vision, that we then change the unit to be 40 units each. So whenever you're working within a 60-degree cone of vision and your canvas is touching or close to the 60-degree cone of vision, then we also need to use units that are appropriate for that lens. So a unit that is, between 1 foot and 6 feet is good. So usually the way that I say this is whenever you're creating a 60-degree cone of vision, which is more of a standard lens, we're using tens of feet. And by that I mean, 1 to 10, right? You wouldn't go 20 because that would be too much. Then when we go to longer lens, we're using hundreds of feet. So we're doing anything from, you know, somewhere around 20 feet to, I don't know, 250 feet. And then if we're doing short lenses, it'll be tenths of feet. So we're doing something like anywhere between a quarter of a foot and a half a foot distance. All right, so now that that grid is done, I'm copying it, and then I'm going to clear all of the junk out of all of these layers that are using the units the way that they were with the 60-degree cone of vision, and we're going to recreate this whole scenario using the same exact units in 2D scale, but we're going to change them. Instead of it being 4 feet, those are going to be 40 feet units. That is all we're changing, that and the cone of vision, and then we're going to fit the picture plane or the portal with inside this new cone of vision. So now that this is 40 feet, I've decided that my ground line is going to be 40 feet from the horizon line, from eye level. So we're 40 feet up in the air now. And then I'm going to shrink the canvas just for posterity. We're going to delete the cone of vision and then redo the cone of vision. So keep in mind that nothing else changed except what I said that the unit scale is going to be and what I'm saying that the cone of vision is going to be. So we're going to calculate a 30-degree cone of vision. That means 0 is centered, and 30 units will be 3 tick marks, or 1.5 tick marks. So in between the two numbers on the right. So center of the triangle is 0. On the right is the first number, which is 10. And then to the right of that is 10 more. So that means that halfway between those two numbers would be 15. And if I move over to the 15-degree mark and I double that, I get 30 degrees. So that's 15 degrees on the left, 15 degrees on the right. And that totals 30 degrees. So we're going to go ahead and create that 30-degree mark on the horizon line. So notice that that line is passing through that 15-degree mark. So that's 15 degrees to the right of center. And as it hits the horizon line, we're making a tick mark, and then that will now be a 30-degree cone of vision tick mark. And then we'll erase that cone of vision line. Now that cone of vision line is not meant to touch the cone of vision itself. It's that mark that's on the horizon. So from the center of vision to that mark is what creates the cone of vision. So we're going to go ahead and create a circle. Actually, I have to change. Sorry, I wasn't color coding things properly, so got to do some color adjustments real quick to fit the consistency of the colors that we were using in the previous grid. So now we're creating a circle. And then I'll scale it up to where center is right above the center of vision, and the edge of that circle is touching the 30-degree cone of vision. Now, because I'm using the iPad and Procreate, there's no way to know where the center of this circle exactly is, so I'm having to sort of eyeball it a little bit. So it's going to take a couple seconds of adjustment. Now this doesn't have to be accurate, like 100% accurate. As long as it's within the ballpark, we at least know that the image that we will create with inside this cone of vision will be somewhere within 30 degrees of cone of vision, right? So there's that chart that I gave you guys access to that has all of this information on it. You can go ahead and check that out, and it's got like what lens number 30 degrees equals, right? So we go through all of the lenses, and I give you guys an idea of which cone of visions equal what lens types, or what lens millimeters. So right now I'm just creating a frame or a portal that fits within inside this space. it doesn't really matter where it fits, as long as I know that the further away I go from the 30-degree cone of vision, the longer the lens it will be, the lower the cone of vision will be, the lower the distortion will be. So if I decided I wanted to use a 30-degree cone of vision, then I probably want to put part of the canvas close to the cone of vision itself. So I'm just fiddling around with things right now. Once I'm done, we just picked the color that I needed for the Z orthogonals. Now, I want you to note here that I'm using thicker lines right now, and then I'm going to undo all this and use thinner lines. Whenever you're closer to the smaller end of the spectrum as far as cone of vision is concerned, you need to use thinner lines and you need to have higher resolution, because your resolution, once you get closer to the horizon line, if you do not have a high resolution image, then you will not be able to create a grid that that is clear. So notice already I'm starting to see that those lines off on the right are so close together that they're almost touching. So I realize that, and I have enough resolution on this canvas to where I can reduce the size of my lines and get a more accurate result using the 30-degree cone of vision, which in fact is a longer lens. So longer lenses are more about capturing something that's further away from us. So now each of these units are 40 feet, right? So that means that we are really, really far away. We're at least, we're at least 300 feet away from the canvas right now. And we are magnifying that scene that is far away. Okay, so now we've got, it's the same exact measure points, but now we have to find a new anchor point, which is going to be the same exact location as the last grid, except now you can tell that the measure line is far more compressed. It's the same amount of units across, the horizontal length of the image, same exact amount of units, which I believe it's 13 units. So we have the same exact amount that we had before, same exact distance as far as unit is concerned, except they are just a different scale. We decided they were just different scale. And now, because of its compression, because we're super close to the horizon line, and everything else was exactly the same. Our measure points are exactly the same. The way we calculated our cone of vision, our station point, everything else is exactly the same. But because we're creating a grid within the 30-degree cone of vision, and we adhered to the principle that when you're doing something that's longer lens, you're in the hundreds of feet. When you're doing something that is standard lens, you're within the tens of feet. And when you're doing something for the wide angle lens or the short lens, you're within tenths of feet. Because we're adhering to that principle, we now have a grid that's being created that has a lot of depth to it in a very, very tiny amount of space, which we'll visit that in a few minutes. And hopefully, once we visit how much space is actually here, it'll make complete sense on what the cone of vision is actually helping us achieve. So not only do you have to know which cone of vision you want to use, but also based on the cone of vision that you're using, you need to decide on a unit scale that's appropriate for that cone of vision. So scale and cone of vision go hand in hand. And they're sort of arbitrary. I mean, I don't have to use this all the time, but in general, your scale and your cone of vision need to match. So the longer the lens, so if I go down to 20-degree field of view, I might, instead of 40 feet, I might have went 80 feet per unit. And if I go to let's say 10 degree field of view, instead of 80, I might be going 200 feet per unit. But the further out I go, the smaller the unit feet becomes, right? So the more standard, I'm more in the tens of feet. So like each unit can be 10 feet, or each unit can be 5 feet, or 6 feet, or 2 feet, or 1 feet. And then when I get to wide angle, I'm looking at 0.5 feet, or 0.25 feet, or 0.05 feet, things like that. Currently, we are calculating the depth of the grid. We have a lot more units on this one going back in space, but each unit is 4 feet, and we have a 52 total feet in this grid depth-wise. In the longer lens, so that was standard, in the longer we have 40 feet units, but we only have a few of the units going back in space, but we still have 320 feet deep. Now we have 13 units going across in both the longer lens and the shorter lens, or the standard lens. And in this particular case, we have 520 feet width. And those 520 feet by 320 feet equal 3.82 acres. I'm not sure if you've ever seen an acre or been on an acre of land, but this is 3.82 acres in this small space. Many things can fit on an acre. And in this particular case, we've got, in the standard lens, we've got 52 feet deep, but we've still got 13 units wide times 4, which is going to give us 52 feet wide. Okay? So that means in this one we have 13 units back by 13 units to the side. This is a perfect square. So we have 52 by 52 feet. And that's going to give us a square acreage of something like 0.06 acres. So this is a huge difference. This isn't even a 0.6 acres. This is 0.06 acres. The actual difference between this standard lens, 60-degree cone of vision grid, and the scale of the longer lens, 30-degree cone of vision grid, is a 64th. So just by shrinking the canvas and pushing the grid up closer to the horizon line relative to the whole system, right? So the grid is not closer to the horizon line if the station point is closer. So relative to the position of the station point to the center of vision, the vanishing points to the measure points, and the distance away from, or the distance between the station point and the center of vision that the ground line is, that distance directly affects the scale of our grid, right? The size of our grid. And so 0.06 acres, which is standard, this standard lens grid is 0.06 acres, is 1/64th the size of the 3.86 acre grid in our longer lens. Now keep in mind that I changed the unit scale for the longer lens because that is an appropriate thing to do, right? So no matter what, if I have 60-degree cone of vision, it's more tens of feet. If I have 30 or below, it's more hundreds of feet. And if I have above 60 degrees, we're looking at fractions of a feet, okay? So if you use these terms and these ideas wisely, you will be able to choose how your final image feels just by choosing the appropriate lens. And lens choice is the main choice that you need to make in order to get across a specific feeling with inside your images. And feeling is what we're going for. We're going for a specific feeling, and this is directly tied to that. So I hope that this made a lot of sense, and you guys understand a little bit more about what the cone of vision is, how it's used, how to control it, and I'll see you in the next video. Take care. Make sure you hit that like button too. Thanks. Peace.